Unit 7, Day 9, Scatter Plots. Today we're going to be able to answer the question, how can you use a scatter plot to make conclusions about data? So the first thing we want to define is what a scatter plot is. A scatter plot is a graph that shows the relationship between two different data sets. So in the example at the left, we are talking about a graph concerning laptops. And the two data sets that we are comparing is the price in dollars and the hard drive capacity, or the gigabytes. So the first thing that they would like us to do is they would like us to draw a line to approximate the data and write an equation of the line. So remember back from line of fit, we want to draw a line that goes through the majority of our data points. So if we want to have about the same amount of dots on either side or on our line. So let's draw a skinnier line that we can see. So if we start at 0, 0, can we draw a line that has about the same amount of dots on either side? So I have about the same amount of dots on both sides. So what can we conclude from this? Can we write an equation of the line? Well, of course. We need our slope and our y-intercept. So our slope, or our m, we can find from two ordered pairs. So I know one ordered pair is at 0, 0, and I know that my other ordered pair is at 12, 1400. So I can do my rate of change, 1400 minus 0 over 12 minus 0. And 1400 divided by 12 gives me a slope of 12 divided by 2 is 6. 1400 divided by 2 is 700. 700 over 6. I then know my y-intercept. My graph started at 0, 0, so my equation of my line is y equals, my slope is positive 700 over 6x plus 0. What conclusions can we make from the equation that we wrote? So for our y-coordinate, our change in y is talking about our price. So this right here is talking about our price. Our 6 is talking about our gigabytes. So every 6 gigabytes cost $700 more. Describe the data comparing the x values to the y values. So as our gigabytes or our x values increase, our y value or our price is also increasing. So the number of gigabytes increases as price increases. So the next thing we want to talk about is a correlation. A correlation is a relationship between data sets. So it is just asking what is happening between our x and our y. So the first example we have is called a positive correlation. A positive correlation, as x increases, y also increases. And our dots are close together in an increasing manner. A negative correlation our dots are close together in a decreasing manner. So as x increases, y is decreasing, so they're doing the opposite. The first one, positive correlation, they're doing the same. And last, no correlation, the points show no pattern. So this is scattered everywhere. We then talk about a correlation coefficient, and our correlation coefficient we denote with the letter R. This tells how closely a line models the data set. So if our dots are really, really close together and increasing, we say it has a strong positive correlation because it's close to one whole. If our R is close to -1, it would be, our points would be decreasing, but are really close together. And we would say this is a strong negative correlation. No correlation is when our dots are scattered about our coordinate plane and are not, they form no relationship at all. If R is close to 1 or -1, the model is considered a good fit. If R is close to 0, the model is not a good fit. If R is equal to plus or -1, the model is a perfect fit with all the data points lying on the line. If R is equal to 0, there is no linear relationship, so we can't even draw a line. So for each scatter plot below, the first thing they want us to do is tell whether this shows a positive, a negative, or no correlation. And then they want us to determine, is it close to 1, -1, or 0? So looking at our first graph, talking about the age of a vehicle owned, they compare the two data points, the number of vehicles owned to the person's age. And you can see that the number of vehicles owned compared to the person's age, all of our points are all over our graph. So we would say this has no correlation. And our R, or our correlation coefficient, would be 0 because it does not form any type of a line. When we look at the second graph, they're talking about the temperature and coat sales. So they're comparing the average daily temperature to the coats sold per day. So as our average daily temperature is increasing, X is increasing, our coats sold, our Y, are decreasing. So when we have a negative relationship between our data points, we have a negative correlation. And is it close to -0 or 1? Well, because our correlation is negative and our dots are close together and look similar to a line, we say it would be closer to -1. On the last graph, we're talking about smoothies. More particularly, we're comparing the sugar, grams of sugar, and the calories. As our sugar increases, our X values increase, our calories also increase. So they have the same, they're doing the same thing. So we would say this is a positive correlation. And when we look to see if our points are close to 1, our points are close to the line. So we would say our correlation coefficient, or our R, is equal to 1. So a line of fit is a line drawn on a scatter plot that is close to most of the data points. So the table shows the weekly sales of DVDs and the number of weeks since the DVD was released. So the first thing that we want to do is we want to plot this information on our graph. So if you label your x-axis as your weeks, I'm going to count by 2s. So that I get a good picture of what's happening. So my x-axis is my weeks. My y-axis they told us to label as our sales. Our title is weekly DVD sales. Our sales, I'm going to count by ones. And then we're going to plot this data. So in week 1, I had about $19 million in sales. On week 2, I had about 15 million. Remember, our sales are in millions. So if you want to label that, that'd be good. Week 3, I had about 13 million. Week 4, I had about 11 million. Week 5, I had about 10 million. Week 6, about 8 million. 7 million. 8, about 5 million. So then it says, write an equation that models the DVD sales as a function of since it was released. So the first thing that we want to do is we want to draw a line of fit on our data. So going through the majority of my points, my line of fit, to make your line go through the majority of your points, I say that looks pretty good. So my y-intercept is 18 million. My slope, if you pick 2 points on your line, so we could use this ordered pair, this ordered pair, this ordered pair. So to go from let's say, so to go from 215 to 313, so 215, 313, we use our slope formula, so 15 minus 13 over 2 minus 3 equals 2 over 1. So our equation would be f of x equals 2x plus 18. So for every 2 weeks, for every week we decrease. So interpret the slope and the y-intercept. So our y-intercept would mean we begin with whatever our starting price was, our starting sales. So in this case, in terms of our problem, it would be $18 million. And our slope is how is our data changing. So for every week, our sales decrease by $2 million. And you just interpreted data based upon a line of fit. You now can complete your day 9 worksheet.